All right, this is going to be the assignment that goes over feature modeling. So in this assignment, we are going to be creating this AC bead lock connector nut. So far, we've been creating sketches and extruding them to create 3D components. We can also use these sketches and extrusion methods to actually take away from previously created 3D components to create features. And that's what we're going to be doing in this assignment. So this nut might look a little bit complicated, but once we start doing it, I think you'll realize that it's not as hard as it seems. So let's go ahead and jump on in. When you open up NX, don't forget to change your role to advanced. And we're going to open up a new file. This will be a model. We are in inches. That's going to be homework 6. Remember to save yours and the desktop. Now to start off on this nut, we have a hexagon shape. So we're going to start off with a sketch. We're just going to choose the top plane. Hit OK. So we're not going to use the profile to make all 6 of those lines. Instead, what we're going to do is we're going to come over here to More. And we've got an ellipse and we've got a polygon. Now the polygon is what we want. So we're going to click on polygon. And this is where we get to, it's asking us to specify a point. Before we do that, we get to select the number of sides of the polygon. We want to stick with 6 so we can get this hexagon. There's some other information down here that you could mess with. We're just going to go ahead and specify our point. We're going to go ahead and select the center, that center point. And we want to fix our hexagon so that the pointy edge is facing up. We can go and close out of that. And then looking at our drawing, we've got from flat to flat is 1 inch. So I'm going to choose this side. I'm going to choose that side. And I'm going to dimension this 1 inch. Now, because we constrained the polygon when we created it, we constrained it so that the center point of this line is on this x-axis. This is now fully constrained. It cannot rotate, and we've defined it as 1 inch from flat to flat. So we can go ahead and finish this sketch. And we want to extrude this 1 inch. Make sure we have 1 inch. And hit OK. Now we've got a hexagon solid body. And what we're going to be using our feature modeling techniques to do is to create this tapered edge and then also this recess section as well. So that's the features that we are going to create by using sketches, and then we're going to turn those sketches into some 3D geometry. Really, the biggest difference is that we are going to, instead of creating that geometry, we're going to subtract from previously created geometry. So let's go ahead and start by creating this feature here, this sort of tapered edge. And this is why we wanted to make sure that we had the pointy end of the hexagon in this orientation, because what we want to do is we want to create a sketch on this YZ plane. So go ahead and create a sketch. And we want it on this right plane. So go ahead and select the right plane. And you see how Sketch is oriented like along the x-axis? To make our life easier, we want to change it so that Sketch is readable from this orientation right here. So really we want Sketch to be right here. What that means is that we want the origin for our sketch to be at this point, and then we want this to be our horizontal axis. So we've selected our plane. Now we can select the orientation. So we can just click on select horizontal reference. We click on that, we get to select the horizontal line that we want our sketch to be on. And I'm just going to select this edge right here. Now when I click on it, Sketch is now in the right orientation, but it's not in the right location. And so to move that sketch up to right here, I'm going to click on specify origin point. And then I just want to click that edge of extrude. Now the origin of our sketch is at this point right here. And that's exactly what we want. So I'm going to hit OK. And now we're right here. If we had done it before where it was over here, then our orientation would look like this, as if we wanted to sketch down here. We don't. We want to sketch right there, and we want it to be in this orientation. And so remember, we're making this feature right here. So what I want to do is I want to make a sort of triangle feature that is going to be in this shape. So I know that the bottom point is dimensioned by this 0.75. The angle is dimensioned by this 30 degree. And that's all the information that we need to be able to actually make that feature. So I'm going to go to my profile tool. I want to select that origin that we just made. I'm going to come down. I'm going to come over just somewhere. And then I'm going to come back across. Make sure we're back on that origin. And I want to dimension that 30 degree from this line to this line. Now, if you can't select this line, make sure that you are within work part only. If you're in just the sketch, then you're not going to be able to access any of the geometry or the lines that we've created with other sketches. You can only select the sketch that you're in. I can select the axis that we have, but I can't select any of the other lines that we've created. But I want to be able to reference this line so I can get that 30 degree. So I want to change my filter right here to within work part only. Now I have access to other geometry, other lines, shapes, features that we have already made. And so I want to say that from here to here, it's all the way over there. Now I just want to change it so that it's 30 degrees. And then I want to say from this bottom point to the center of the nut is half of 0.75. And so what I can do is I can click on that point, and then I can come over here still with making sure that we have within work part only, and click on the origin. It might be kind of hard to see, but we have those dimensions that have popped up. And I want to choose the one that is going from this point down to the origin, which is going to be this linear dimension right here. And I want to change this so it's half of the 0.75, because remember we were told that the 0.75 was the diameter but we are referencing the radius here. So I'm going to do equals 0.75 divided by 2. And now this sketch has been fully defined. So I can come up here to finish. And with that sketch still selected, instead of extruding this like we have done, I want to revolve it. So the revolve is similar to the extrude, except for the fact that we are taking that 2D sketch, we're creating 3D geometry, a 3D shape, by revolving it around an axis. So I'm going to hit revolve. It's already selected the curves because that sketch was still selected. But now it's asking me to select a vector and a point. And we've gone over this before. If it just specify a vector, the purple arrows show up, and I can select a vector direction, but then I still need to specify a point that it's going to rotate around. So we could do that, or we could just select an axis. And this is what I want this to rotate around the center of the nut. So this is going to rotate around the z-axis. So I can select the z-axis. And it's rotated around. Now it's taking away material instead of adding material like we have done before. And that's because of this Boolean selection that we have down here. We haven't messed with this yet because we haven't had to until now. So with this drop-down menu, we have some options here. We've got none. And if we select none, what'll happen is it'll create a whole separate 3D model. So that means there will be two different bodies, three-dimensional bodies in this one model. That's usually not a good idea. It's typically not what we want to have happen. So that's not what we're going to do here. So we don't want none. If we did unite, it's going to take the geometry that's created by revolving this, and it's going to combine it with whatever body we have selected. And it automatically selects the only other solid body that's in the model. This we use a lot for various reasons. Then we have intersect. And what intersect does is the only solid body that's actually created is the area where the two solid bodies intersect. You can see here it's that sort of grayed in area. That's what would remain if we did intersect. Then we have subtract. So what subtract does is it takes the new 3D solid body that's created, that area, and it subtracts it from the solid body that you have selected. So the solid body that we've selected is the hexagon shape that we just made before, and it subtracts the new triangle shape that we just created from it. And that's how we get this angle. And that's what we want. We want to subtract. So we could hit show results. And that is what we want. So we can hit OK. So we've got this feature here that is done. Now we're going to use a very similar method, pretty much the same exact thing, to create this recessed feature here. So again, we're going to create a sketch. We're going to do it on this right plane. But I don't want to start a sketch like this, because if we did, then it would orient itself here and we'd be sketching around this origin. I know that we need our sketch to be here. I'm going to go ahead and change our horizontal reference to that same line we had before. And then when I specify origin point, I want that origin point to be up at the top. We're going to say, okay. And then just like with the triangle section, what we want to do is we want to create a shape that we can revolve around the nut and remove this area. So we have this 45-degree, and then we have this 100 thou, and that is what's being removed. So let's go to our profile tool. I'm going to start at the origin. go over, come down at an angle, cut across, and then go back to the origin. So we know that this angle is 45 degrees. We know that the length of this line is 100 thou, 0.1. And then if we go back to our drawing, that's information that we have here. And then over here, we're told that this diameter here is 1 inch. So we're going to do similar to what we did with the 0.75. I'm going to orient this, and I'm going to say from this point, from this bottom point to the origin right there. I'm going to stay consistent with the way that we've been doing this. I could put in 0.5 and that would work just fine, but I want to stay consistent with what we've been doing. So we did that 0.75 and we said equals 0.75 divided by 2. I'm going to stay consistent. I'm going to say equals 1 divided by 2. I want to stay consistent with what we're doing. Now our sketch is fully defined. We can finish and do the same thing that we did before. So my sketch is still selected. I'm going to go to revolve. Our curves are selected. Go to our vector. And I'm going to choose the z-axis. And we want to make sure our Boolean is subtract. We can say show results. And that looks good. We hit OK. All right, so we've got the angle that we have here. That's done. We have this section here. That's done. Now we need to do is make the holes. So we have 2 holes here. We've got this 0.562, and that's this smaller diameter right here. And then we have this tapped hole. So tapped holes are holes that have threads. And that is this box that's right here. So this 0.500, that is the depth of the threads. You can even see it on the call out here. So we've got a 7/8 9 TPI UNC 2B. It's not a through hole as far as the threads go. The threads go to a depth of 0.5. The tap drill that's called out is a 0.766, and that only goes to 0.7 inches. So this is going to be 2 separate holes for us. So let's go ahead and make these holes. So we're actually going to start with that tapped hole first. So let's go to our hole command. And we don't have a simple hole. What we have is a threaded hole. And before we mess with any of the threading information, let's go ahead and select our hole. So we're going to do it a different way from the ways we've done it before. What we want is we want to be able to select the center point of really this circle. And so the way that we can do this is, see, as I approach this circle, see how it turns yellow and then it snaps to the center? What's happening is we're snapping to the arc center. And that's really what we want to do, is we want to snap to that center point. So it can be kind of hard to do sometimes. So you kind of got to do it a little bit slowly. But you see that line that turns yellow, and you can wait until the 3 dots appear and then click and then specify the arc center. That way we don't have to go into a sketch. We don't have to create another point when we already have a point there. It's just the center of that arc. And this is a nut that's always going to be in the center of that arc. So we've got our point specified. Now we can go and change our information here. We are going to be in UNC. We have a 7/8 9 TPI. Our radial engagement, we want to change to custom because we have been told on the drawing that we have a tap drill of 0.766. And so we want to be able to change that tap drill diameter. So we've got a 0.766. Our thread depth type, our thread depth, again, we've been told is 1/2 inch. So we don't want like 1 times diameter or any of these. We want to actually go to custom. And we want to change this to the 0.5 inches. We want to leave the start chamfer selected. It's not called out on the drawing, but we can see that there is a chamfer there. So we can go ahead and leave it on there. The tap drill is a diameter of 0.766, but it's only going down to 0.7 inches. And that's what this rectangle is right here. That is the tap drill. And then this wireframe box, that's the threads. So we've got the 7/8 9 TPI. Our tap drill is 0.766. We've got the 1/2 inch for the threads. We need to specify that this only goes down the 0.7 inches that's called out. And the way that we do that is right now we've got a through body, but we don't want a through body. We want a value. We want a value of 0.7. But if we look at the drawing, it's the 0.7, but we have this flat right here. It's not tapered like a drill bit angle would have. It's a flat bottom. So at the tip angle, we're going to put 0 degrees. And that's going to change it so that it's got that flat bottom right there. And we can hit OK. And you'll say, where are the threads? And that's a fair question. So NX does not model the threads. So one way that we can actually see the threads is, well, just coming over here and seeing, well, that's a threaded hole, but we can actually change our view style to static wireframe, and you see these dotted line circles. That's the threads. So we can do the static wireframe. We can add some translucency and we can see those threads. That's how we see the threads in NX. Okay, so it's not going to show up modeled. All right, so the next hole that we need to do is this 0.562 through hole right here. It's got a couple of rounded edges. So let's go and make this hole. So we're going to go back to hole. And we don't need a threaded hole. We can just use a simple hole. We don't need a start chamfer or an end chamfer. We just need it to be 0.562 inches in diameter. And we can either come from the hole that we just created, and it's the same method that we've used before, or we used to create this hole where we approach that circle and it's going to snap to the center of it. We could also do it from the top where we approach that circle and it's gonna turn yellow, and we can snap it to that arc center. Now we want a through hole, a through body. And we can hit OK. Now on that drawing, these are rounded edges. These aren't chamfered edges. And so how we do that is we come up here to edge blend. So what edge blend does is it rounds the edges. It doesn't cut them at an angle, it rounds them. So we can click on the edge blend command, and it's asking us to select our edges. So we have this inside edge here, and then this outside edge. And we have a 30 thou radius, which is 0.030. We can say show results. And see how it just kind of rounds off those edges there. That's what we're looking for. Well, we can hit OK. And there is our nut. We can go to view. We can edit section. Along the y-axis or the y-plane. Get a good side view. We can see the threads just to make sure that everything looks about right. So make sure that you submit this to the Dropbox. And thanks for watching.